Hey everybody. Today we're graphing some tangent and cotangent functions. As is usually the case in trig, when we deal with tangent of x and cotangent of x, we're going to use the quotient identities. Tangent x is sine x over cosine of x, and cotangent of x is cosine x over sine of x. These two identities alone give us a lot of information about the graphs of y equals tangent of x and y equals cotangent of x. Almost enough to graph them right off the bat. First of all, the zeros of tangent of x are going to be the same as the zeros of sine of x. You can see that just from the formula tangent of x equals sine x over cosine of x. Whenever the numerator is 0, the entire fraction is going to be 0. This is going to occur at 0, plus and minus pi, plus and minus 2 pi, and so on. Similarly, the zeros of cotangent of x are going to be the zeros of cosine of x, plus and minus pi over 2, plus and minus 3 pi over 2, and so on. These are all going to correspond to x-intercepts on the graphs of tangent and cotangent. Similarly, when the denominator of each of these has a 0, then the entire function, tangent or cotangent, is going to have a vertical asymptote. The vertical asymptotes of tangent of x are the same as the zeros of cosine of x, and the vertical asymptotes of cotangent of x are the same as the zeros of sine of x. This tells us directly the domains of tangent and cotangent. The domain of tangent is all the real numbers that don't make cosine of x equal to 0, so all real numbers except pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and so on. And the domain of cotangent of x is going to be all the real numbers that don't make sine of x equal to 0. So all real numbers except 0, pi, 2 pi, negative 2 pi, and so on. Finally, and slightly less obviously, the ranges of tangent of x and cotangent of x are both going to be all real numbers. Here's the basic graph of y equals tangent of x. As I said on the previous slide, its vertical asymptotes are at plus and minus pi over 2, plus and minus 3 pi over 2, and so on. Notice also that the period of this function is pi, half that of sine or cosine, and that it's always increasing on its domain. Similarly, here's the graph y equals cotangent of x. It has vertical asymptotes at 0, plus and minus pi, plus and minus 2 pi, and so on. Its period is also pi, and it's always decreasing on its domain. When graphing other more complicated tangent or cotangent functions, you should always start by identifying the asymptotes by using the corresponding cosine for tangent or sine for cotangent functions. Basically determining when that cosine or sine is equal to 0, and then sketching in your vertical asymptotes using that information. Let's do a couple of examples to see how that works. First of all, y equals the tangent of pi over 3 times x. This function is going to have vertical asymptotes whenever cosine of pi over 3 times x is equal to 0. Of course, cosine is 0 at plus and minus pi over 2, plus and minus 3 pi over 2, and so on. So basically, I want to take the inside of that cosine function and set it equal to plus and minus pi over 2, plus and minus 3 pi over 2, and so on. Here are the equations I get. I'm going to multiply both sides of each by 3 over pi to get the equations of my vertical asymptotes. X equals plus and minus 3 halves, x equals plus and minus 9 halves, and so on. The vertical asymptotes repeat every 3 units here. More generally, if you have y equals tangent of a constant b times x, or y equals cotangent of b times x, then the period is going to be pi divided by b. So now that we know the vertical asymptotes, we're ready to start sketching this graph of y equals tangent of pi over 3 times x. I've drawn in the vertical asymptotes with dotted lines here, and I know that the zeros are going to be halfway between those vertical asymptotes, and that the graph is going to increase from one asymptote to the next one. So here's what the final graph looks like. Let's do one more example. Y equals cotangent of 1/5 x. Here we're going to get vertical asymptotes wherever sine of 1/5 x is equal to 0. Sine is going to be 0 at 0, plus and minus pi, plus and minus 2 pi, and so on. So I'm taking the inside of that sine function, 1/5 x, and setting it equal to 0, plus and minus pi, plus and minus 2 pi, and so on. To solve these, I'm just going to multiply both sides of each equation by 5. So the vertical asymptotes are going to be at 0, plus and minus 5 pi, plus and minus 10 pi, and so on. Here, the vertical asymptotes repeat every 5 pi units. We can also see that using the formula from a couple slides ago. Period equals pi over b. Here, b is 1/5. So we get period is pi divided by a fifth, or 5 pi. Let's sketch in the asymptotes here. Again, every 5 pi I've labeled an asymptote starting at 0. For a cotangent, I know that the graph is always going to decrease from one asymptote to another, with an x-intercept halfway in between. So here's what the final graph looks like for y equals cotangent of x over 5.